Hello class, and hope everybody's having a great day. Today we're taking a look at sections 5.6 and 5.7 from your textbook, and that is the sine law and the cosine law. We put these together because they both represent operations or calculations you perform that has been different from the rest of the units. So up to this point, every triangle or every calculation we've done has been based on a 90-degree or right triangle. Today, when we use sine law and cosine law, we're going to be dealing with called oblique triangles, and they are non-right triangles. So to draw an oblique triangle, it's going to look something like that. Okay? The good news about today's lesson, folks, is it's mostly a review from last year in grade 10 when you did law of cosines and law of sines, and it's much easier, I find, than trying to deal with trig identities. We will come back and review trig identities prior to your test. However, for now, we're going to go with something that should be of a little bit more comfort to you. Okay? So ladies and gentlemen, just remember for all of examples today, there's no 90-degree angle. If you had a right angle, you would be using either Pythagorean theorem, SOHCAHTOA, special triangles, or rotational angles where you could drop a 90-degree angle from. That is not the case right now, so we are dealing with what's called oblique triangles. Okay, and oblique triangles, again, have angles that are acute or obtuse, but do not have a 90-degree angle in them. All right, so let's take a look at the first law called the sine law. And in order to use sine law, you must have a match. Okay, and a match, ladies and gentlemen, is what we call an angle and its opposite side. Okay, and maybe your teacher last year made you circle that and say, hey, there's a match, because maybe this angle's given and maybe that side length's given. Okay, so once you have a match, you can hopefully have another piece of the information to solve another part of the triangle. The sine law is based on proportional ratios. And is set up as such. A, which is the side length A, over sine A equals the side B over the sine of B, which equals C over the sine of C. Okay? Although, ladies and gentlemen, there are three proportional ratios in here, we will usually only use two ratios. Because quite often not that much information is given in a triangle trig question. Okay? This formula, ladies and gentlemen, I just drew is used for when you're calculating the length. So notice that the lower letters A, B, and C, they represent length, and they're on the top. The other type of formula you could use, that is the sine formula, is just flipping the fractions. So say we had something like sine of A divided by side A equals the sine of B, which is angle B, divided by the length of side B, equals the sine C over the side of C. Okay? This, again, ladies and gentlemen, is used because on top you have the angles, so that's why we kind of flip it to find the angles. Okay? All right, let's try a couple examples here of, actually one example of sine law. And just remember, to use the sine law, you must know one angle and its opposite side, and that's what we call the match that I explained earlier. Okay? All right. Ladies and gentlemen, let's look at example 1. It says to find A. Now, A, ladies and gentlemen, is lowercase, so that's side A. Okay? We look at our triangle, and remember your process is, look at the triangle first. Do we have a 90-degree angle? We don't, so that means we can't use special triangles, we can't use SOHCAHTOA, we can't use Pythagorean theorem. That's all out the window. So all we have left to do is decide if we're going to use sine law or cosine law. Sine law is when we have a match. Do we currently have a match as it exists? No, but can we get a match? Absolutely. What you need to realize is with geometry, ladies and gentlemen, we can find this side C. So side C equals 180 degrees. Subtract the two given angles, which is 78 degrees, subtract 55 degrees. And if you're not sure, that's the theorem, angle sum triangle theorem, or ASTT for short. Plug that in your calculator, ladies and gentlemen, and now we know that's 47 degrees. Once we put 47 degrees in, we now, ladies and gentlemen, have a match. Okay, so to explain, that is the second part of the proportional ratio we're going to use, and we're going to find the first one in the first ratio. So what we're looking for is A, so A goes over sine of A equals, and what side do we have information in? The C, so it's side C over sine of C. Notice here, folks, we're not worrying about information B because we don't have the side length of B, even though we have the angle. Okay, so let's sub in the information that we know. I'll just go over here so I don't run into room. Subbing in the information we know, we got A over the sine of 78 degrees equals side C, which is 28, over the sine of 47 degrees. Okay. Remember back to when we were doing some proportional ratios. To find A, we're going to do the opposite cross. So A equals 28 sine 78. And you're going to divide by what you would normally multiply, which is this sine 47 degrees. Again, you want to get A by itself, so I'm just saving a step. And ladies and gentlemen, you plug that in your calculator, and A equals approximately 37.4 meters. All right. Now we're going to deal with what's called the cosine law. The cosine law is used again when you have no 90 degrees, so you're looking at an oblique triangle and you don't have a match. So there's going to be two cases where you have a cosine law. Okay, and the first one is where you've got side angle side. Okay, we call that also a contained angle. Okay. And what you're going to be doing in that case is you're going to be finding the opposite side length. So find opposite or other side, because the other two sides are given. Okay, that's case one. Case two, ladies and gentlemen, is where you're given a triangle with side, side, side. That means no angles are given. Okay. And what you're going to be asked to find here is you could find any angle. Oopsie. Find any angle. Okay? Because there are three different angles and three different side lengths, we could have three formulas for each. However, I'm just going to give one, and we'll learn how to do the patterning or how to fill it in. And this should be a recall from last year. Okay? So if we're taking a look at finding the side length, so case one where you got side angle side and you're finding the opposite side length, let's take a look if we wanted to find C squared. So C squared equals the other two sides squared, so that's A squared plus B squared. Subtract 2 times those two sides, which is 2AB, and times the cos of the angle that's given. In this case, it would be given angle C. Okay, so that's for finding a side length. And again, that's going to be your case of side angle side given. Okay. The other formula, ladies and gentlemen, is just a rearrangement of this, and if you're finding the angle C. So let's say we want to find the angle C, so cos C is going to equal the other two sides squared, subtract the opposite side. This is the one where you got to be careful in terms of your order, and then we're going to divide it by 2 times the other two sides. Okay, and that's, again, finding the angle, okay, and that's if you're given side, side, side. Okay, I will provide you those two formulas plus the sine law formula on your test. You don't need to memorize them. You just have to know how to sub them in and use them. Okay, so to use cosine law, you must either have all three sides, so that's your case side, 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 or you have what's called a contained angle, and that's your side angle side method. All right, let's take a look at this example 2 here. It says to find theta. So theta currently is cos C. So what we're going to be doing is saying cos C, just like the formula up there, is going to be the other two sides squared. So it's going to be a squared plus b squared. Subtract the opposite side. That's your key there, guys. Divided by 2 times a b. Let's sub in what we know. Cos, you could leave it as C, but I'm just going to change it to theta because it's given us theta, equals A, which side A is 9 squared, plus side B, which is 8 squared, minus C, which is 15 squared, all divided by 2 times 9 times 8. Okay? I've taught in the past to simplify the numerator and the denominator, and I will continue to have that patterning here. So plug all the numerator into your calculator, and you should get negative 80, divided by your denominator, which is 144. Remember, folks, that to find an angle, you've got to use the inverse button. So you're going to go cos inverse of this fraction. Okay. And in this case, folks, you're going to have that theta equals 124 degrees. Okay? I want you to think back now that we've got some more tools here, ladies and gentlemen. Notice how this ratio up here is negative. Okay? Okay? When you look at the final answer, which is your angle, 124, according to the CAST rule, that would appear in what quadrant, guys? In quadrant 2, where cos is negative. So that's just a quick double check to make sure you're applying the CAST rule. So just let me write that out. Okay, we had an angle of 124, right? So that's here. And in that quadrant, it's negative, so that is why our ratio is negative for that case. Okay, just another tying in our CAST rule. All right, last example for today is finding Q. Okay, so Q, ladies and gentlemen, is a side length. You might want to put that in on your diagram. All right, so basically what we're looking for here is Q squared equals the other two sides squared, which is P squared plus R squared minus 2 times PR times the cos of the angle given Q. All right, so taking a look at subbing this in, we have P, ladies and gentlemen, which is 7 squared, plus R, which is 11 squared, minus 2 times P, which is 7, times R, which is 11, times the cos of the given angle, which is 20 degrees. Okay, plug that in your calculator. And last year I taught you how to simplify the first part first, so do that. So plug that in your calculator, and you're going to get 170. And then you know what, subtract and do this, all this bracket information together. And let's round to like 2 decimal places because we still aren't finished yet. So it's going to be 144.71. Simplify that through, class, and you're going to get that Q squared equals 25.29. Don't forget, in order to get Q, folks, you have to take the square root, just like you do in Pythagorean theorem. Okay, finishing this off, Q equals approximately 5.0 meters. All right, ladies and gentlemen, there we have our sine law and cosine law. Again, we're looking at oblique triangles. So your homework today is page 318, numbers 4, 7, and 8, and page 326, numbers 3, 5, and 10. Have a great day, guys, and see me if you need any help.